Hello and welcome. And in this video, we are going to cover the 4 RayCastAlls. Actually, the Physics.Cast.all. So the first one we're going to look at is RayCastAll. So I'm just going to rename this game object to Physics.CastAll, and I'm going to create a new class, RayCastAll. And as you will notice, I'm working in Unity 6. So the class will be a copy of the original RayCast. And then we're just going to add a new for loop. And I'm going to copy that and then change it to RayCastAll and make this actually equal to a new allocation of an array of raycast hits, which is what this function wants me to do. As you can see, we have already put it in the most complicated function, which is the most overloads you can pass into that function. Now, instead of did hit, we can actually check if the length is greater than 0. If it's not, that means we got no hit. If we do, we want to use the ray hits at rayHits.length -1 and just replace it where we want to use it. And now in the for loop, we can use the rayHits.length and draw a wire sphere at the index position of the ray hits and just set the color to red. I'll add the component to the Physics.CastAll game object and set the max distance to 2. And as soon as I give it the layers, you can see that if I add more objects, it's going to detect all of the objects in the same range. That's the difference between a normal raycast and a RayCastAll. So it returns all of the hits. The raycast would return the first one only. In this one, it looks at all that are in the range of the range that we pass in meters. So that's why if I go out of range, we don't get the hits anymore. The next one we are looking at is our SphereCastAll. Now, it's pretty similar. It also will just return all hits, but using a sphere shape. Again, we'll copy it from the sphere class this time and change it to SphereCastAll. Then we need to remove the out raycast hit. Instead, we need to get it from the function, as that's what it returns to us, a raycast hits. And then use its length -1 as the index. Now we'll assign the color to a slide blue and draw a wire sphere. We need to actually do a for loop so we can go over all of the hits and just a 0.3 radius for this sphere. The statement's going to be simple, just like last time. And now we can add the component and set the layer to everything. And we have this big sphere which we have drawn previously. We can cut that out actually. Now we can see the hit point only. So as I move over to other places, you'll see the hit point is not only once, many, because the sphere is pretty big in size, 0.5. And it's like sweeping a big sphere downwards in the direction we've given it, and getting all the hits in the range. That's what a SphereCastAll does for us. Alright, the next one is the BoxCastAll. So we'll create a new monobehavior script, and this is going to be a BoxCastAll. You're going to get the copy of the code from the BoxCast and paste it into the BoxCastAll. Okay, we will now change this one into a physics.boxcastall and remove that state class and then make it accept an array and then use the length and pass the index to get the distance. And before changing the matrix, we will actually do a for loop to draw all of the boxes. gizmos.draw wire cube, and we'll use the point at the index and the size. And now let's see what happens. So I will add the script, set the layer, and as you can see, the boxes might not be aligned with one of the boxes because the hit point of a box cast is going to be one of the edges, and that's why it doesn't come the correct position, and we were using the distance for that one, that's why. But we don't want to actually align the box directly. Instead, we can draw a wire sphere. We just want to show that the hit points are actually coming in this array. So now you'll see that that sphere is going to come wherever the hits are found, as you can see right here as well. So the last one is going to be a CapsuleCastAll, and we will make a mono-behavior script for this one as well. This is going to be the CapsuleCastAll, and we'll get the code from the CapsuleCast. Then we'll use the CapsuleCastAll and remove that out RayCast hits info and add an array for the Physics.CapsuleCastAll function to get its results. Then use the RayCast hits at index RayCast hits.length -1, and before that we'll do a for loop to draw all the hits for it. We will draw the hits using gizmos, and draw a wired sphere at the point of this index ray hit and a simple radius. Now you'll see we can set the layer and we get the first hit point, and if we move it up so that we can actually fix the issue where it's not overlapping, so there you can see all of that, and we can actually create a new capsule, attach it, and for some reason it's not working. Yeah, it's not working for some reason, but we can fix that, I guess. It's not in the script as the capsule cast works. Actually, it's we have to remove the collider on this object to fix this. Yeah, so I'm just going to remove it, and now it does as we expect it to. Now, as you can see, we're getting correct hits. So if you would throw the whole capsule cast down that, you would get these hits that it's showing us. These are all the hits that are possible in the range using a capsule shape. Alright, so make sure to subscribe and like